So this is the 2021 paper 2 question 3 on differentiation and integration. So given that y equals to this, show that dy dx is this. So all I'm going to do is just differentiate using my quotient rule. Right? Quotient rule, I always start from the denominator. Right? This thing would just square. And since I start from the denominator, I'm not going to touch my denominator as well. And I'm gonna differentiate my numerator. Differentiate x, I just get it to be 1. Quotient rule in between is a minus, so write the minus out. And then now I'm going to differentiate by denominator. Bring down the power. Power minus 1 becomes negative half. Right? Differentiate the inside, which I just get 2. Because I differentiate inside, it's just 2. And I'm going to leave my numerator, so it's just x. From here, you can see that here, the question wants you to actually get power 3 over 2 at your denominator, which means at your numerator, you have to factorize out 2x plus 1 to the power of negative half, because we will have to bring this down to our denominator later on, right? And what we are left with inside, because I take out a negative from half, I'm left with 1 inside, right? So I'm just left with 2x plus 1. And 2x plus 1 times 1, right, times 1 over here, I just get 2x plus 1. Next, I take out this whole term because I take out a negative term. That whole term disappears. My 2 and the 2 cancels out, so I'm just left with minus x at my numerator. And at my denominator, my square cancels out with the square root, so I'm just left with 2x plus 1 to the power of 1 at my denominator. Afterwards, I just simplify both sides. At my numerator, 2x plus 1 minus x just gives me x plus 1, okay? And at my denominator, I'm just going to shift this down, and I get it to be 2x plus 1 to the power of 3 over 2. And here you would have shown. Okay, so that's part A. So just make sure you're familiar with your quotient rule. Make sure you know that you need to factorize this out. Part B, they tell you, hence find the integral value from range of 0 to 4 of this x over 2x plus 1 to the power of 3 over 2. For every hence question, make sure that you always copy down, for the differential and integration style questions, make sure you always copy down your dy dx first, because we need to start from a differentiation, right? So our dy dx previously, we know that it equals to x plus 1 over 2x plus 1 to the power of 3 over 2. And here what I'm going to do is I'm going to integrate both sides, right? Integrate both sides so that I can get my y to appear where. So I integrate dy dx with respect to dx, right? And at the same time, I will integrate the other side, x plus 1 over 2x plus 1 to the power of 3 over 2 dx. And when I integrate dy dx, I just get back my y, right? And my y is also the same as x over 2x plus 1 to the power of half. So I'm just going to write that down. X over 2x plus 1 to the power of half. And on my right hand side, right, you can see that actually this fraction over here can be split into 2. Right? We need to split it because we have an additional plus 1 over here. Right? In my answer, I do not want to have a plus 1 over here. So I will split it apart, and what it becomes is just 2x plus 1, right, 3 over 2, right? Because I just split it apart, meaning to say I just get the integral of 1 over 2x plus 1 to the power of 3 over 2 dx. Right? So I split it apart as such. And don't worry about the range yet, we can always do that at the very last step. But more importantly here is that you need to recognize that this is what I want. So what I'm going to do with it is I'm going to rearrange my terms slightly so that I can make this the subject. In essence, I'm going to bring this over to my left hand side. Okay, but before bringing anything to anywhere, I always like to integrate this first so that I don't get confused later on. Right? And I know that I want this to remain as is because I'm trying to find the integral of this. So this one just don't need to touch it. So in the end, I get this to be, this side remains the same. Right? My integral here, I want it, so I just leave it to be the same. And I just need to be able to integrate this. This is also the same as 2x plus 1 to the power of negative 3 over 2. So here, my power plus 1, right? I get it to be 2x plus 1 to the power of negative 3 over 2 plus 1, I just get negative half, divided by power, which I divide by negative half, divided by the differential of the inside, which I just divide by 2. Right? My denominator just cancels out to just give me negative 1. So this thing can be simplified into just negative of my numerator lah. Okay, so I'm just simplifying it. On my right hand side, it remains the same. Sorry, on my left hand side, it remains the same. Right? X over 2x plus 1, 3 over 2 dx. And on my on my right hand side here, this just becomes negative because of the negative below. And this becomes 1 over square root 2x plus 1. Once I have this, I'm going to rearrange my terms, meaning to say I'm going to bring this over to the left hand side. And I'm going to rearrange it a bit, right? Making this the subject. So it becomes integral of x over 2x plus 1, 3 over 2 dx is equals to this term, right? X over 2x plus 1 to the power of half. And I'm moving this over, so from the minus, it becomes plus 1 over root 2x plus 1. Okay, I'm going to make this a bit smaller because I need a bit of space. Right, so I'm going to make it to look like this. And now, once we have finally gotten my integral to where I want it to be, I would then sub in my boundary conditions of 0 to 4. Of which here, there's no need to integrate it anymore already because the integral of this thing just equals to this. So all we need to do after this is actually just sub in values, right? What values to sub in? We have 4 and 0. So when we sub this in, all we're going to get is 4 over, okay, this part, try to use a bit of your mental sums to do it quicker, right? 4 times 2 plus 1, okay, is basically 8 plus 1, which is 9. Okay, 9 square root, right, because power half, okay, it's perfectly fine to just write it as square root 9. Plus, the other side would be 1 over, my denominator again is 4 times 2, which is 8. 8 plus 1 is again just square root 9. So this is my very first term. My next term, right, when I sub in my 0, my first term just becomes 0 because x becomes 0. Right, my second term actually has a number. It is 1 over, this term becomes 0, so you're just getting square root 1. Right, and in between is a positive, so it's a plus 1 over square root 1. Okay, all you need to do is press this in your calculator. So 4 over root 3 is just root 9 is just 4 over 3, right? And then 1 over root 9 is 1 over 3, so it's 4 over 3 plus 1 over 3. And I'm minusing away 1 over root 1, which is just minus 1. And in the end, I just get this to be 5 over 3 minus 1. I get my answer to be 2 over 3. And this is your final answer. Okay, so I recap again for the steps for this integration question. First thing to do is always to write down your previous part of what you differentiated, right? Your dy dx. Afterwards, when you have written that out, you need to integrate both sides, right? So integrate both sides. Third step is to split it apart where necessary to get the real integral which you are interested in, right? In this case, the real integral I'm interested in is this term. And of whichever other term that you don't require, just make sure to integrate it accordingly, right? Integrate it accordingly and move that term over to the other side, which you don't want it to be, right? Because we only want our integral x over 2x plus 1 to the power of 3 over 2. So you just isolate that term out, right, over here. And afterwards, all your other terms should be on the other side. Once you have this, then you include your integral boundaries, right? This should be the very last step, include your integral boundaries. And then afterwards, you just solve for your integral. Okay, so this is how you do this question.